We will continue our discussion of binomial random variables today, and we'll calculate the mean, variance, and standard deviation for a binomial random variable. You can see here in the first table that the mean, mu, is found by taking n multiplied by p. So the number of items multiplied by the probability of success. The variance is found by taking n times p times q. The standard deviation is taking the square root of the variance, so the square root of the product n times p times q. The first example we'll work today is telling us that if x is a binomial random variable, calculate mu, which is the mean, sigma squared, which is the variance, and sigma, which is our standard deviation, for each of the following. So what we're doing is calculating the population mean, variance, and standard deviation. And that's why we're using mu to represent population mean. And sigma is involved with variance and standard deviation. So remember, to find the value of q, you are finding the complement of p. So q is equal to 1 minus the p-value given. In our first example, we have a total count of 30, so n equals 30, and the probability of success is given at 0.6. So first we calculate the value of q. Q is found by taking 1 minus the p-value of 0.6, and that leaves us 0.4. So to calculate our population mean, we are taking n, which is 30, multiplying by p, which is 0.6. So 30 times 0.6 is equal to 18. Next, we'll find the variance. The variance is found by taking n times p times q, which will equal 7.2. And now we can find the standard deviation. So if we know that sigma squared is equal to 7.2, to calculate sigma, we're taking the square root of 7.2. So that gives us 2.683, and there we have our standard deviation. Let's try another example. Now we have an n value of 65. P value is 0.4. So Q needs to be calculated, and that would be 1 minus 0.4. So our Q value is 0.6. Mu represents our population mean. That's calculated by taking n times p. So 65 times 0.4, and that equals 26. So the mean is 26. Sigma squared represents our variance. That is found by taking n times p times q. 65 times 0.4 times 0.6, and that equals 15.6. And finally, sigma represents the standard deviation. So we're taking the square root of 15.6, and that is about 3.95. And there we have our standard deviation for the binomial random variable.